All right, this is in class example 6. It's problem 647 from the other textbook. You can see the rectangular beam, and they want us to find the maximum stress if the moment is applied about the z-axis, so it says it's shown here, or about the y-axis. So that would be turned on its side. And then they want us to stress or sketch the stress distribution for each case. So let's go ahead and get started. Oh. We're going to start with case A. So it's about the z-axis as it's shown. So we need to find, we know stress max equals mc over I. And I guess this is in the case of doing the moment about the z-axis. So I'll include those there. So we need to know what the I of z is. And for a rectangle shape, I is 1/12 base times height cubed. And in this case, the base would be the 200 millimeters. So here, and then the height would be the 150 millimeters. So 1/12 times 200 millimeters times 150 millimeters cubed. And that gives us 56,250,000 millimeters to the fourth. And so now we can find the maximum, and the maximum stress is going to occur on one of these edges. So maximum compressive would be up at the top, the maximum tension would be at the bottom. But either way, that distance would be this distance here, which would just be half of that 150 millimeters. So C is going to equal 75 millimeters. And so now we can find that maximum stress with that formula we found already. We already wrote it down. It equals M. And M was given as 90 kilonewton meters. So I'm going to write 90,000 Newton meters. And then we're going to change that to millimeters. So 1,000 millimeters divided by a meter. Meters cancel out. Then times C, which is 75 millimeters. And then divided by that IZ, which is the one we already calculated. So 56,250,000, or sorry, 56 million millimeters to the fourth. And we have millimeters squared on top, so that changes to squared on the bottom. So we get newtons per millimeter squared, which is megapascals. So let's see what we get with that. Wait, 120 megapascals. And then while we're doing this one, let's go ahead and draw the diagram. So we have, so I'm just going to start with the shape that we had up here. So I'll redraw that here. Basically have something like this. And then the maximum stress is going to occur. So the neutral axis is through the middle. The maximum tensile stress is going to be up at the top, or sorry, compressive stress. So it'll be pressing in. So let's see if we go out here. So it'd be something like this. And all these arrows are going in because it's compressing here. And then those are going to go down to 0 at that neutral axis. And then it'll go back up. I didn't draw this great. Go across here into there. And for this side, it's actually going to be in tension, so the arrows are pointed out. So if we could see through here, it would be like that. but this is actually all sort of solid here. Um, sorry, it keeps erasing my stuff. Um, so that's roughly what that looks like. And then we can do the same. So now we want to do the same, but we want to move that moment to where it's going about the y-axis. Um, so the moment would be something like um, this moment about the y-axis. And so let's do that one now. This is part B. So same, so stress max is going to equal, or for B is going to be MC over IY. The C, the C is going to be 100 millimeters. So it's this distance here will be our C. So C equals 100 millimeters. The moment is the same value, so it's the 90 kilonewton meters. So M equals 90,000 Newton meters. And then IY we need to calculate. For a rectangle, IY is 1/12 base times height cubed. But now we're doing it about this other axis. So the base is actually going to be this one, so the 150 millimeters, and the height is going to be 200 millimeters. So we'll turn it up on its side. Um, so that gives us 1/12. The base is the 150 millimeters, and then the height is that 200 millimeters cubed. And that gives us one, is 100 million. Let's see, 1, 2, 3, 4. Yep. Just making sure I have the right number of zeros written down. And so now we can calculate that stress max for B. It equals 90,000 Newton meters. Let me get rid of those meters. Change it to millimeters. Times C times 100 millimeters divided by IY, which is at 100 million. So the millimeters cancel out. So we get newtons per millimeter squared, which is megapascals. And we'll calculate that really quick. We get 90 megapascals. And then we need to sketch this one out also. So it's that same base shape that we had. So here, and roughly the same. This one, the moment is going across this way, so the neutral axis is down the center. And then let's see, the way we drew it here, the tension would be on the right side. Let's see if I can get a different color. Mm, So I'm gonna go down to the center and back up. Um, and the tension is on the right side, so like this. And then it'd be compression on this side. It would be the opposite if we drew it in the other direction. Um, and that's it.